Hey, it's Mr. Redstone, and in this video we are going to be solving some multi-step equations involving fractions. You might see them called rational equations, but we're going to keep the denominators free of variables. So if we use this idea of DCI, distribute, combine like terms, and use inverse operations, we're going to be fine. And to make you feel more at ease with this topic, the first thing I'm going to do is show you how to get rid of the fractions. You notice how I put that 2 over 1, because what I'm looking for is a common denominator, 3, 6, 1, and 2. That common denominator is 6. And what you see me doing here is multiplying both sides of my equation by 6. This is the multiplicative property of equality and is a completely legal maneuver when you're trying to solve these types of equations. So now that I've multiplied by 6, I'm going to distribute. 6 times 2x over 3 is 4x. 6 times x over 6 is x. And 6 times 2 over 1 is 12. On the right-hand side, 6 times x over 2 is 3x. And lo and behold, we have no fractions. We can now combine our like terms on the left to get 5x plus 12 is 3x. So now I've got variables on both sides. I'm going to subtract 3x from each side. Leaves me with 2x plus 12 is 0. The inverse operation of adding 12 is to subtract 12. 2x is negative 12, and the rest is easy. We divide both sides by 2 to get x equals negative 6. So the only thing that we've done here that was different is we got rid of the fractions by multiplying by the lowest common denominator. Next question, we see a 6, a 5, and a 3 in the denominator. Start thinking about what's the common denominator. If you can't come up with a good way of doing this in your head, you could always just multiply 6 by 5 by 3. In that case, it would be 90. That is a common denominator. It's not the lowest, but it would work. So the lowest common is actually 30. So I'm going to multiply both the left and the right by 30. The left-hand side looks just like the previous example. The right-hand side looks just a bit more complicated because I already have a coefficient in front of that bracket. But now I'm saying I've got 30 of these 4 times 2x plus 1 divided by 3's. On the left side, we distribute. 30 times x over 6 would be 5x's. 30 times 3x over 5 would be 18x's. And on the right, what I'm going to do is just clean up all of these coefficients. I've got a 30 times a 4 divided by 3. Mentally, the way I do this is 30 divided by 3. That gives me 10. 10 times 4 is 40. And what I'm going to do now is distribute the 40 into that 2x plus 1. Doing that would give me 80x plus 40. Using my DCI, I can now combine my like terms. On the left, I've got 5x's plus 18x's to get 23x's. On the right, I have 80x's plus 40. So next, I'm going to subtract away 23x's from each side to maintain equality. Leaves me with 0 equals 57x plus 40. We want to isolate the variable term by getting rid of that add 40. We do that by subtracting 40. Negative 40 equals 57x. And now to isolate the variable, we'll divide by 57. And I'm trying to think, does that simplify? I don't think it does. So our answer is negative 40 57ths. It's not the prettiest number, but, you know, that's just the way these go sometimes. Last one. Now there's more than one way you can attack this question, but I'm just going to be consistent and go along with this DCI thing. I look at the denominator of 4 and 3, and the common denominator there is 12. So I'm going to multiply both the left and the right-hand side by 12. Now keep in mind, this is not the only way you can do this problem. So I've got 12 times 3 times 1 minus 2x over 4 is 12 times 4 times 2x minus 1. And I gave you an extra bracket just as a bonus, all divided by 3. So with each the left and the right, I'm just going to clean up that coefficient. I've got 12 times 3 divided by 4. That's 9 groups of 1 minus 2x. On the right-hand side, I've got 12 times 4 divided by 3. That's 16 groups of 2x minus 1. And now it's pretty straightforward. We can just distribute both the left and the right-hand side to get 9 minus 18x equals 32x minus 16. Using inverse operations, I'm going to eliminate the variable on one of the sides. I'm going to go with the subtract 18x. So to get rid of that, I add 18x. And whatever I do to one side, I do to the other. 9 is equal to 50x minus 16. We add 16 to both sides, and we're almost done. 25 is equal to 50 times x. And please don't say it's 2. We divide both sides by 50 to get 1/2. And that's it. Now there's at least 3 ways that I could have done this problem, but every way is going to end up with that answer of 1/2. Here's a shortcut that some students kind of like. This is actually set up as a proportion. If you look at it, I've got 2 equivalent fractions. The left and the right-hand side are just one big fraction each. So theoretically, you could cross multiply and divide here. Their cross products are going to be equal. So if I were to cross multiply, I would get 3 times 3 times 1 minus 2x equals 4 times 4 times 2x minus 1. And then if I were to clean up my coefficient in front, you would see that I'm back to where I started with on the previous question. And that is a little bit easier, but your question has to be set up just perfectly. That method that I showed you would not have worked on the previous questions. So that's all for this video. Thanks for watching. See you next time.